So, hi everyone, welcome. My name is Teacher Brendan, and you are here for the XCamp Python trial class. Now, this is a beginner class. The expectation is that you don't have to know anything about programming at all in order to join our class today. So if you don't have any experience with programming, welcome, you're in the right place, and we are going to learn some new things about it today. Like I said, my name is Teacher Brendan. I've been teaching at XCamp for a very long time. I've taught something similar, our very entry-level class, which we call the 100 level class, where we learn Python along with a library that we'll learn about called Python Turtle. And I've taught all the other classes in between, all the way leading up to our 300 level courses, which are more designed for students who are interested in competitive programming. So yeah, I have a variety of experience with XCamp. I really enjoy this trial class, and I hope that you enjoy the class today. It's going to be really fun, and hopefully you learn something interesting. So I'm going to share my screen, and the first thing that I want to do with our class today is two things. The first thing I want to show you is that we have this in XCamp, this learning website that we have, our learning website. Now, if you're an XCamp student, you would see this as your home for everything that you could possibly need. So for example, when we have slides in the class, when we have some information, you'll have that within the course for your class. Here we have the trial class. So these are the slides that we're going to go through today. So you'll be able to see that. Also, what you would be able to see normally in your class is each week you would have a homework problem set. So you'd have a couple challenging problems to solve, and you would be able to submit them to our learning site for grading. And we have some other resources as well that are really helpful within our site. So everything that we do within the learning site is within the learning site. So if you're wondering what you're looking at today, this is our site that I present the materials, and also we submit homework and do so much more on. Okay? All right. So the first thing I want to share with you are some class rules. Now, the trial class is a little bit different, specifically because we have so many students, right? We often have maybe somewhere between like 50 and 100 students, or sometimes even more, who are joining our class. So it's a little bit challenging for me to get to know you on a personal level, especially just with one class. But yes, usually we would have all of our students have their camera on. If you do have the ability, and that's okay with you, to turn on your camera, that would be really great, just so that we can make it a little bit more like an in-person classroom, and I can see you, and it feels like we're all together in the same class. However, if you feel uncomfortable turning on your camera, or you have some problems with your camera, that's okay. I totally understand. This is the trial class. And the other rules that we have are, we really want to be respectful in our XCamp classroom. We want to make sure that we are polite to our teacher, that we are polite to our classmates. All of us will have different levels of experience. Some of you may already know how to write some Python code, and some of you might not even really know very much about what programming is. Our job is not to compare ourselves to each other. We always want to be supportive of our classmates. And if a classmate doesn't know something, that's okay. We're all here to learn. And so it's important that we treat each other with respect all the time. Now, specifically in a trial class, what I've done is, in order to make sure that the Zoom chat doesn't grow too large with a bunch of questions and students chatting back and forth, we've set it up so that you can just chat directly with the host, which is myself, the teacher, or with our two wonderful TAs, okay, which are marked as co-hosts. If you have a question that you would like to ask through chat, please feel free to do that. But just know that it will go directly to either myself or one of our TAs. The third rule that I want to explain is class participation. Now, in our XCamp classes, it's not really like a class where you just sit back and watch like you're watching YouTube or something like that. It's really interactive, and the teacher is talking, and we're asking questions directly to the students. We do tons of coding, practice problems and challenges. And so just so you know, it's a lot of interaction, and it's not quite the type of class where you just sit back and watch and don't write any code and just listen to the teacher talk. When you join the class, the expectation is that you participate and you join in and you do the exercises. Now, for today, because it's a little bit tough to manage a lot of students in terms of speaking up and communicating and all those things, we've set it up so that you guys are muted. And if you would like to answer a question, please raise your hand within Zoom, and I will call on you. Okay, so we're going to pause for a second. Does everyone know how to use the Zoom raise your hand icon if you want to ask a question? If you know how to use it, please take a moment to raise your hand in Zoom. I'm not going to call on you. I just want to see if everyone can do it. Okay, I have everyone in gallery mode, so let's see if I can see everyone raising their hand. Yeah, okay, this looks really good. I think almost, let me scroll through the pages. I have a couple pages. Yeah, I think we have a good amount of students raising their hand. I even saw one student using the clapping emoji. So it looks like good. Yeah, we know how to raise our hand. So if I ask a question and you would like to participate, please feel free to raise your hand and I'll call on someone to help me out. There definitely will be moments in here where I need to have some students help me to answer some questions. Okay. All right, great. So, and the last thing is the Zoom name. Now, we want to record everyone who's joining us here today. And then also, when I call on you, I want to make sure that I call you by the right name. So please make sure, especially if you're using maybe your parents' Zoom account or something like that, to edit the Zoom name for yourself and make sure that it matches what we have on record. And that way, I can address you properly. And if you would like to go by some sort of nickname, that's not your official name, you can always maybe put it in parentheses and I'll call you by that name instead. Okay, great. So if you currently have your hand raised in Zoom, feel free to click the button to lower your hand, or else starting right now, I'll think that you might have a question. So just lower your hands. If you do have a question, feel free to keep it raised. And if not, we can get started with our class for today. So let's first go over what we're going to talk about today and get an idea of what we are here to do. So what are we going to learn? Well, we're going to talk about coding. We're going to talk about what it is, what are the things that we can use it for. And once we get some ideas, we are going to talk specifically about a programming language or a way that we can write some code. And specifically today, we're going to pick that language of Python. We'll talk about why we choose Python, what we can do with Python, what are the benefits, and other things like that. Now, after we do that, we're going to learn a specific library, and we'll learn about what this word means in some time. We're going to use a library called Python Turtle, and that's going to allow us to do some drawings with Python. And we'll see that it's a really fun and interactive way of learning programming, where we can create these drawings from the code that we write. And then after we do that, we're going to talk a little bit more big picture and sort of getting an idea of beyond just the very first class in XCamp, what can an XCamp student expect to learn over the course of several semesters, quarters actually, with an XCamp. For example, in the very first class, the 100 level class, moving all the way up through the 300 level, and even beyond if you're interested in competitive programming, or maybe going on to study coding in college, or doing research, or other things like that. So at the end, we'll talk about some ways, some things that we learn in our higher level classes, as well as just what these things apply to in real life. So we get a better idea of what's the whole point of learning coding and Python in general. Okay. So let's first start about what is coding or programming. I'm using this word programming, and sometimes I'm using this word coding. You might think, oh, they're interchangeable. And yes, in this case, they are interchangeable. And programming, what it is it's just simply our way of giving instructions to the computer to tell it to perform some task. And we're going to give it instructions step by step. So you can almost think about, let's say, has anyone been in the kitchen, maybe, trying to make a recipe, right? And trying to cook something or maybe bake something. You would have some instructions, and line by line, you would follow the first step. Maybe you need to get some ingredients ready, and then maybe you need to heat up the stove or the oven. And it's going to be very similar in that way, where we are going to be giving instructions to our computer so that it can perform specific tasks for us. So you'll hear me say the word programming or coding. Oftentimes we call it coding for short. Okay, what can we do with coding? So what I've done is I have some photos here to give you some inspiration about some of the things that we can use coding to build in real life. So take a look at these photos here and see if you can understand the connection between these photos and coding, and even take a moment to think one step further and say, beyond the photos that teacher Brendan is showing me on the screen, what are some examples in real life that we use coding that affect our lives? So does anyone want to raise their hand and help us out and tell us either one example from here on how it's connected to coding, or maybe they want to give us their own example that's not directly one of these photos? Okay, I see Eric. Can you unmute yourself and tell us something about coding in real
Well,
life?
for the Minecraft picture, which is at the bottom right,
Mhm.
it people um uh, people code Minecraft to for other people to play it and be entertained. And for the bottom one in the middle, they code the robots to do things for them. And in the bottom left one, they use code to animate a movie so people can watch and be entertained.
Yeah, those were some really those were some really good examples. Thank you, Eric, for sharing. I'm just curious, does anyone either have any interest in maybe in the future writing some code to, um, either help out a game or build your own game or other things like that? Anyone interested in coding with games? I'm just curious to see. I'm always interested to see which of my students like games or are interested in games and other stuff like that. That's awesome to see. One of the fun things about XCamp is we although we have a lot of like homework problems that teach us to solve these little coding puzzles, we do have some projects as well, that we can build to show some of the skills that we learn in the class. And there are a couple classes that have some really cool games that you get to build along with it. So that's always one of my very favorite parts of XCamp class, is that you get this cool project that you can do and you can build out a game. Yes, so um, there's a lot of stuff going on that involves programming. We have to write some code to draw these pictures, right? How do these characters how do they show up on our computer screen? And then also even further, this is a game, right? So the user or the player of the game, they're going to be maybe clicking the mouse or they're going to be pressing the keyboard, or even in, like, for example, a video game, you'd be pressing a button, and then our computer program, it needs to listen to those instructions. And let's say that your character needs to move left or right based on some arrow keys, then it needs to listen to those instructions, and it needs to update that photo on the screen, that image of where the character should move. So that there's a lot of coding involved. And I really like this example, and also the Pixar one as well, because it's kind of similar to some of the things that we're going to do today. So yeah, that's pretty exciting. And I see two other students have their hands raised. I can go to Luke. Luke, can you help us out with maybe something else, a photo that you see up here, or another example that's not on this slide? Oh, he had his hand raised, but I think his hand went down. Do I have any other students who want to share an example or pick something from here? Maybe I can give some hints. What's this one in the top left corner? Oh, I see some hands. I'm going to call on Guillermo. Guillermo, I'm going to ask you to unmute.
Right.
Can
Uh,
you? Hmm?
so the always see the little car at the bottom, like bottom middle. I think if you like can create an app and like do certain codes, like you can move a joystick to move the car, like move a joystick on the screen and the car moves.
Yeah. Yeah, that's really right. Yeah, thank you for sharing that. This is so what we have in this bottom middle section. This is like a little robot that has a hand that can grab stuff and move around. So this is just, I mean, the robot itself, it's just a machine. It doesn't move unless we tell it to move. And how do we tell it to move, right? When we push the joystick to tell the robot to move forward, how does it know to move forward, right? Someone has to write some instructions that say when this button is pushed forward in this way, the robot should have some reaction to move in that way, right? And even we can go so much further beyond that to say not only can we write our own instructions for how the robot can move, but we can write instructions to teach the robot how the robot should make decisions on its own. Has anyone heard about heard this idea of AI or artificial intelligence? Yeah, it's a super popular topic right now. And it's really fun to think about. And essentially all those kinds of things come from code, from computer code of writing instructions and sort of teaching the computer how to make decisions on its own, right? And getting this feedback and deciding how to change and get an outcome that's favorable, right? So that's another example. And also one thing that Guillermo mentioned was this idea of apps. Applications live everywhere in our lives, and they will continue to, right? And so whether it's a cell phone, for example, this one in the top right corner has lots of applications. Well, when you press the button to open the application, well, how do you decide what happens when you press a button or you type some input into a search box? Well, someone had to write some code to decide how to handle or how to process all of those situations. Right? So here, all these applications had to be written with some code, with some engineers building this so that it can understand what you're trying to do. How about, I'm curious about this one in the top left corner. How about this example? Does anyone want to raise their hand and tell me what does chess have to do with computer programming? Anyone have any ideas? I have a couple students. I'm going to ask Aiden. Aiden, can you help me out and maybe give me a hint about this chess one?
Yeah. You're able to use AI by like using bots you are able to program like bots to play real players.
Yeah, that's a great answer. Thank you for sharing. So I'm just curious, do I have any students who play chess at all? I'm always curious because when I teach the summer camps, I often have a lot of students who like to play online chess on like chess.com. They have their own profile and rankings, and sometimes we bring a board and play together. It's really fun. It's really fun. But if you don't have someone to play against, right, you can always play against a robot, right? Now, how does the robot know how to make a move, right? I don't know if anyone's played on chess.com or any online like chess tools, but sometimes you can select like different levels, maybe easy or medium or hard, expert, things like that. How does the robot know where to move the piece, right? That's something that's interesting for us to think about. Well, the instructions for the robot, since it's not controlled by a person, it needs to be from a computer program, right? So all these examples are showing us of technology and code is absolutely everywhere in our world. and it's not going away anytime soon. It's just going to be more involved into our world. And so it's a really great opportunity to say, hey, I have these interests. I'm interested in artificial intelligence. I'm interested in games. I'm interested in apps. I'm interested in websites. And I want to learn how to write code so that I can build whatever my mind imagines. And I think that's the most awesome thing about being an engineer and being able to write some code is that you can think things up in your mind, and then you can go to your computer and write some code to make it real in real life. And so that's really, really satisfying thing. Okay. All right. Yeah. So here are some examples, and I'm sure that as you sort of look around and notice in your life other examples of technology and ways that coding come about, it's all over the place. So how do we write code? Well, we start out first with a computer, right? And with a keyboard and potentially a mouse. And we need some sort of way of writing these instructions. We're not going to write just regular English sentences to our computer. We are going to use something called a coding language. Okay? There are thousands of coding languages. And maybe in the future, you even invent your own coding language. But for now, for today, we are just going to sort of talk about and then start with some of our most common coding languages. So I'm just curious, from these ones that I showed here, has anyone heard or maybe tried out one of these programming languages and maybe can share, if possible, what you think, in real life you might use this specific programming language for? Okay, let's see some students who have their hands up. Eric Yang, can you help me out? Do you see something on here or maybe want to share an example?
I've done Python before.
Okay, can you tell me a little bit about what you built using Python?
Like doing while loops and lists and other stuff and working with variables.
Yeah, that's awesome. And some of that stuff we're going to learn today. So you're going to have one step ahead knowing some of those things. Okay, let's see if I can call in another student. I think was it Cecilia had her hand up? Where did she go? I think she took her hand down. Okay, let's see if I can call on. Oh, Cece, yeah. Cece, can you help me out? Do you have another example for us?
No.
No? Do you have a question?
No. I have heard of them, but I've never like used any of them.
Okay. Tell me about a programming language that you heard about before.
Java, C++, Python, and HTML.
Okay, awesome. And have you heard about any of them, maybe where it was used or what kind of things you could build with it?
For HTML, you can like build websites and yeah.
Yeah, that's exactly right. You can build websites. So the sort of the how everything is laid out within the website is controlled with HTML, and we can make things interactive with JavaScript, this language JavaScript, which is a really popular and powerful language. And then also we can style things, like sort of move things around and decide how it should look with CSS. So these often go hand in hand together, especially if you're interested in building websites. This is something that you would become comfortable probably with all three of these listed below. Okay, who else has an example here that I can call on? Maxwell, can you help me out? Do you have an example here or maybe another example from your life that you want to share?
Okay. So I wanted to say that I've done Python before and professionals use it to create websites and apps, but I use it to have fun with coding. Also, what does that made with secret alien technology thing mean?
I won't go into details. This is something that you'll have to look up on your own after class or join XCamp and ask me. Go look up this programming language called Lisp, Lisp, and maybe you'll see a little bit more about this if you're curious. Yeah, this is not too common. This is just a fun one that we put on here. This is not something yeah, that we teach or even maybe if you were to become an engineer, even most engineers would never write any code with Lisp, but it's good to know about, and there's a lot of history involved with the language Lisp. It's very interesting if you're curious about that. There are so many interesting coding languages for us to learn. And I'm sorry, can you remind me one more time, what did you build with Python when you were using it?
Well, I kind of had fun with coding with it. Like I've used Hurdle before, and I've also created some games that only like use text.
Yeah, that's awesome. Yeah, there's a lot of fun text games that we can make and play. Um, there's a lot of possibility just with some text games, and yeah, that can be fun too. Yeah, so I will say also yeah, thanks for sharing all of your experience. I will say within our XCamp structure, we start out learning Python, and then we transition to learning C++. Why do we transition to learning C++? This is a language that's more suited towards competitive programmers because of how fast and efficient of a language it is. It's a little bit, or it's a lot more challenging to learn and write. However, if you are interested in going down the route of competitive programming, it can be an advantage to knowing a language like C++. And it really, really teaches you to know the ins and outs of how coding works. Python is something that we're going to learn today. And let's move to this next slide here. Why do we learn Python? Or how come in the context of learning programming languages, people always talk about Python? Well, when we are learning a programming language, one of the difficult things about it is the syntax. And what I mean syntax is how it's written, right? So for example, I'm an English speaker, right? I know how to speak English. And if I look at another language that uses letters of the English alphabet, it will maybe be a little bit easier for me to try and piece together how it works and figure things out, versus if I were to read some characters that I don't understand at all, it might be a lot more challenging. So Python, the reason why it's a really great language for us to start out with as beginners is because it looks a lot like English. And you're going to see some of the basic commands for Python are just English words that Python knows how to understand. So it's going to look a lot like us just writing English sentences, and it's going to understand what to do. And so we don't have to worry about these fancy curly braces and semicolons and some other things like that you would need in other programming languages. It's going to look a lot more simple and easier for us to get started without making mistakes. And then beyond that, Python is not just good because it's easy to learn. It's good because it has so much application, and especially as we talk about artificial intelligence, we talk about things like data analysis, and even technically in the web as well. There is so much Python everywhere that we go, and oftentimes, engineers or professionals, although they might not, and some of them will use Python on a day-to-day basis, and even for the engineers who don't necessarily use it on a day-to-day basis, Python is a really powerful tool in case you want to build some quick application or tool or script or something like that to complete some tasks. So it's really, really useful to learn. And regardless if you use it in the future or not, it's a really great starting point for us. Okay, so let's get started with writing our very first Python program. So in our instruction letter to you, we mentioned this coding editor, which is really great for beginners. It's called Thonny. If you had the chance to set that up, fantastic. You can use that and follow along with the class today. If you did not set that up, do not panic. I have a backup plan. I have either, if you're familiar with this website called Replit, that you can use that for writing your Python code, or this other one, which you don't even need to create a login at all, is called Python Sandbox. So I am going to copy the link to the Python Sandbox one here, if you're interested, and I'm going to put it in the Zoom chat. Now, if you have some other editor that you already have set up, you're more than welcome to use that. But just a heads up, we will be writing some Python turtle code, and you will need a graphics a graphics window. So if you don't have that set up, you might want to follow along with the online route or just for today. Okay, so hopefully everyone can see in the Zoom chat, I put a link to the Python sandbox. So for all of my students who don't have a coding environment set up, then feel free to go to that website and it will look something like this. Here, I have it in my other tab. Well, it won't say hello XCamp. But this is, so on the left this is what I wrote. On the left, this is where we are going to write our code. And on the right is going to be where our output is. So if we are in here, let's go back to the slides and let's see this example here. It says we want to write this print hello world. Okay, so I'm going to go back. I'll go first to my Python sandbox and I'm going to press, do you see in the bottom corner, I have this play button. So I'm going to press the play button. And on the right side here, I have my output. Okay, this is when I talk about output, it's what my program is sending to me. So we'll talk about input and output, but this is the result of my program, what my program is giving back to me. Okay, if you were to do that in the Thonny editor, we would still do the same thing. So we'd still write print hello world, and there's even a play button. And then down at the bottom, you would see the output of your program. This is called the console window here. So it will look slightly different depending on your setup. And actually, if you have Thonny set up, you maybe have it in the default look, which is the light theme. I've just customized it for my preference to the dark theme, but it's the same thing. Okay. So now that we've written our first program, let's talk about what's going on and what happened. Well, what happened? When I clicked the play button, I saw that the text I put inside of print is displayed here on this output window. Now, if I were to change it to hello XCamp, something like that, and I hit play, it updates my text in the output window for whatever text I place inside of the print. Now, we have to be very careful because one thing we will learn very quickly with programming is that our computer is not very good at just interpreting what we want. We have to be very precise and exact when we're giving instructions to our computer. So say, for example, I get rid of these quotation marks here. And I say, well, this is the same thing, right, Teacher Brendan? I'm trying to print hello XCamp. And I hit play. And it doesn't like this. Python is giving me an error. Okay? And the reason is because Python is not able to interpret what do I mean. If I want Python to execute something, I have to follow exactly the rules of how the language works. So for example, just think about it. Let's say that we were writing a sentence in English and I was writing something like, hello, how are you today? Okay. Now we're all able to, as long as we're English speakers, we should be able to understand this. And even if I were to do something like this, you still should be able to read the sentence, hello, how are you today? And say, okay, I understand what Teacher Brendan meant. He made a small mistake. He added an extra E to the R, but I get what he means. Computer languages don't work in that way. They're not good at, or they are unable to interpret what you meant. So we have to be very careful and very precise so that we don't make any mistakes and so we don't have any errors with our code. So just make sure that we're very careful of the details as we're following along in the class. For example, if we're writing like T, that's not the same thing as uppercase T. We have to be very precise. So along the way during the class, if you're copying my example, or if you're trying to write your code and it's not quite working as expected, the first thing that you want to do is you want to go and examine your code and make sure that all the letters and all the punctuation and the characters match exactly as they are meant to be in the editor window. Okay. All right. So let's move on to talking about Python Turtle. You said, Teacher Brendan told me about Python Turtle. It's something used for drawing, and that's what we're going to use today. So if you're curious about Python Turtle, what it is a library. If you're not sure what a library is, that's totally normal. And so it's essentially a way in which we can render drawings. We can create these drawings with our code, with our Python code, and we can display them in a window. Now, when I go back to the Python sandbox, or if I'm writing my code in Thani, notice how when I print or I send this output to my output window, I really only have the ability to create things within the text form. So I suppose that, I could put characters like this, or maybe I can make even like a smiley face doing something like this, right? I don't really have a way of creating any drawings. And that's because our output window or our console window is just for displaying text, okay? So you will only either write, we will write text for our program to read, or a program will print some text to us, but it's never going to create some drawings. In order for that to happen, we need to have a new window that's specifically going to be used for us to render, or when I say render, I mean display our drawings that we create with our Python code, okay? That's where Python Turtle comes to play. So we did not write the code for how to create these drawings. This is some code that the people who are involved with creating Python Turtle created so that we can use. So we are going to use some commands that Python does not understand. However, when we use this library, it's like this, the idea of like checking out a book, now we can have some extra commands that allow us to do these drawings. So that's going to allow us to have this window and to write some commands that normally Python wouldn't understand, but in the context of our library, it will be able to understand and be able to display them as we want to. Now, if you are using the online site and you're following along, we only have one output window here. So I'm going to go to the very top, and if you're distracted right now, you might want to turn your eyes towards the screen and watch me. So what I'll do is I can click on the mode and see how it has this turtle mode here. So when I click this one, it's going to open up a new tab, and it's going to show me a new separate window. So here is where I'm going to write my code, and here is what it calls the turtle window, okay? So remember I was saying that we can't create any graphics with our normal console window. This is the graphics window where we are going to be able to see our code, okay? So if you're following along with the online site, just make sure that you switch over, you go to modes and then turtle mode, and then you can write your code in there, okay? And then also, if we want to go back and play around with our Python, with our output window, we can just go back to our other tab and write that. Now, if you're in the Thani editor and you have everything set up, there's nothing that we really need to switch, right? All we'll need to do is just simply tell Python that we want to use this specific library. And how do we do that? Well, we do that by using this keyword import. And so I'm going to copy this code here, and let's talk about this. So look what happens when in my code editor, when I write this word import. Do you guys see how it turned a different color? So it turns a different color, and even if I'm using my sandbox here, and I write import turtle, even this turns it a different color. And most code editors that you will use, they have the ability to recognize these keywords from Python and say, oh, this is a specific word. This is a very special word that Python understands. And specifically, when we write the word import, what we are saying is that, hey, Python, we want to use some code that's not included in the basic Python programming language. We want to use some code that someone else wrote that we want to check out and collect into our Python program, okay? So how we do that is writing the word import and then along with this library that we want to use, okay? So let's go back to the code, the slides here. The first thing that we want to do is we want to create our turtle. And you might be asking, why is it called turtle? What does drawing have to do anything with that? Just be patient with me. You'll see in a second, okay? So what happens when I go back here? And so here, I'll show you first in my Thani editor, and then I'll go to the online one. So when I click play, I see this new window pops up. Look how this is separate from my output window here. This is my Python Turtle graphics window. And what I see is at the top, it says Python Turtle graphics. And I get this little arrow that's pointing towards the right in the middle of my square window. Okay, let's go and go to the Python Turtle sandbox here. I'm going to copy that same idea. So look how I take this code here. I've named my turtle Ted. You can call it whatever you want. Oops, that's the wrong window. So here, what are we doing? We're importing the library. We're saying, hey, we want to use this code from this turtle library. And we're going to write turtle exactly as the library is named. And then dot turtle, like this, with the uppercase exactly. And then feel free to give it a name of however you like. Now, there are some rules for giving, these are called variables, giving variables names. We're not going to go deep dive into the details of it today. That's something that we will learn with time. However, you might notice that if you give it a name, like let's say I try to give it a first name and last name, like Ted Tedderson or something like that, that this does not work. It says, this is some bad input. This is not going to work. So please just give it a name that's all the words are together, or maybe if you want to connect multiple words, we often do that with, like, for example, in underscore or something like that. But it's maybe nice or helpful to keep it simple. You also want to remember that it's helpful to keep it with a name that means something to you. So for example, if I just call this like X or Z or something like that, later on when I'm writing my code, or maybe I'm showing my code to someone else, they might be confused about that. What does X mean? How do I know? So it's good that you kind of give it a name that has some meaning. For me, I know that my turtle is named Ted, and so that's why I call it like this. And so when I run my code, I have my graphics window on the side, and this is how we're going to replicate them. Okay. So what did we see? Like I mentioned, we see the arrow, and we see the arrow is specifically our turtle. And so let's change that turtle. So what I'm going to do is I'm going to take my turtle and I'm going to give him a shape. So here, I'm going to copy the next line of code, and I write Ted, or the name of my turtle, dot shape, and then I put in quotes this word turtle. Okay, when I hit the play button, you can see that before I had this default shape, which was an arrow, and now I changed that to a turtle. Now, there are some other shapes that we could use. For example, the classic one is just simply the arrow. Then we have another arrow shape. We have the turtle, we have circle, square, triangle, other things like that. Feel free to simply replace the text with something that you're interested in using. But all that's going to do, it's not going to move anything. It's just going to change that default shape. Now, you might be asking, what is the turtle? What is it for? And in simple, all it's doing is we can think of the turtle as our pen, right? So imagine the turtle is our pen and we set it down on the screen. The turtle, we are going to give it instructions on how to move left, right, up, down, and different angles and things like that. And as we do that, the turtle is going to move around the screen. And wherever it goes, it's going to simply draw a line with it. If you're interested in what that's doing, that's how it works. So let's write our first line of code to make our turtle move. We have these two commands, forward and backwards. So let's try them out and see what happens when I use them. Okay, so I'll put my next line here. All right, ted.forward 100. And I run my code, and it was kind of fast, so it's hard to see. But did everyone see how it moved forward? Forward. When I say forward, it moved to the right of my screen. I'll do that one more time so everyone can see. I run my code, and really fast, it moved to the side. And similarly, what I could do is I can move my turtle backwards. So if I go back to my editor, here, I can move it backwards, just like this. Now, we can do a lot more than move our turtle forwards and backwards, but this is a start. And this is how you can see that we're doing the very beginning steps of creating our drawing. And so this is how we can move the turtle. We'll talk in a second about why forward is considered moving to the right. You might think that moving forward would be like upwards, for example, but we will get there when we get to that part. What I'm more interested about is, what does 100 mean? Did everyone see how Teacher Brendan wrote in his code? He wrote ted.backwards or ted.forwards 100. Why 100? What could that possibly mean? Does anyone have any ideas or guesses for us? Do you want to raise your hand and help me out? I'm going to call on someone new. How about Walton? Hey, Walton, are you there? Hey, Walton, are you there?
Yeah.
Do you have an idea of what 100 could mean?
100 could mean like 100 steps.
100 steps? And what do you think 100 steps might mean? So I agree, 100 steps, but probably, a step, we want to think about some sort of unit of measurement, right? What could that possibly be?
Millimeters.
Yeah, millimeters, centimeters, inches. Well, I guess not inches because my turtle would have gone a lot further than what I showed. Those are some good ideas. Anyone have any other guesses that they want to share with us? How about, does anyone know maybe a unit of measurement or a small unit that we often use with graphics or visualizations? Ishani, can you help me out? Do you have any ideas?
Would it be pixels?
That's a very good guess. So what is a pixel? Well, a pixel is just this tiny little unit within our computer screen or our graphic screens. And so actually everything that we're seeing here within our website, within our applications, and any sort of images that we're seeing, all they are these tiny little units, these little squares called pixels. And the reason why we can't see them is because they are so small that when our eyes look at them from afar, they look as if they are not square. However, I'm not sure, has anyone ever, like, maybe you tried to download maybe a photo from the internet for like a school project or something like that, and it was just like really small or low quality, and then you open the image and you can see all those squares, all those pixels from it? Has anyone tried that before? You're looking at some sort of image or some sort of graphics, and you can literally see those square units. Yeah, so the pixel is really what we're seeing. And when Python Turtle is doing its drawing, it's sort of counting out the pixels of how far to move across our screen. And when we want to change the color and other things like that, it will just simply update for each of those little tiny little pixels what the color should be. So like I said, the reason why we don't see the pixels often is because pixels are so small, they give this illusion of a smooth image. So we have that illusion, and that's what helps us to think that we're not really just seeing a bunch of boxes next to each other. So that being said, let's move right along and let's do this next step here, which is to change the color of our pen. So here, what I can do is I can change the color of my pen with Ted dot, or whatever the name of my turtle is, pen color, and then some specific color that I want. Okay, so I have my turtle, I change its shape, let's change the pen color, and then we can move in a direction that we want to. So let's see what happens. Look how the outline of my turtle changed to that color I wanted, right? And then the line, when it moved, it was that red color. Now we have lots of colors that we can use when we're wanting to draw our pictures. And you might say, well, what colors are available to me? Actually, every single color is available to you. Just for today, to keep things simple, we're just going to use these, what we call named colors, where we type in the name of the color, and Python turtle will understand that color and be able to say what does this mean? However, if you are interested about what are your other options, let me show you. So you can look up online, Python turtle colors or other things like that, and you will see that there's some resources online that you can find to show you some colors that are available. So there's so much more than what I've actually put on the slides, which is available to you. For example, this site here, this site from Trinket, this one is pretty cool. You can sort of click around and say, oh, I'm interested in this color, and you can see what the Python turtle name would be. And then we have these values here, RGB. What could this possibly mean? Is this familiar to anyone? Does this make any sense to anyone what RGB could possibly mean? Oh, I have some helpers. Vincent, can you help me out and tell me what RGB means?
So it recites the number of red, green, and blue mixed in to make the color.
Yeah, that's exactly right. And Vincent, can we combine different combinations of RGB of red, green, and blue to make every single color?
Yeah, but it has a limit for the red, green, and blue.
Yes. Do you happen to know what our limits are?
I think it's like 512 or something.
Um, a little bit lower. Anyone want to anyone, I guess, does anyone know what the limits are in limits for how big our RGB values can be? Yeah, Eric, do you know? Eric Ma, do you know? Oh no, you just have your hand up for a different question, or not sure? Okay, Guillermo, do you know?
Sorry, what was the question again?
Oh, well, I guess we were wondering what are the maximum numbers that we could put for these RGB values? I didn't tell you guys, yes, I was just curious if anyone knew.
I'm not sure, but most like values with like electronics are usually 999.
999, maybe. Let's see if anyone, I'm gonna try to keep calling, find someone who knows this answer. Someone new, maybe Jennifer, help me out here. Any idea?
256.
256? Anyone agree? Yes or no or so close? I think I have some people in the chat saying, yes, I see some in the chat. She was so close. The answer is 255. So we could set our values as small as 0, meaning we don't want that specific color, and we can make it as large as 255. For today, to keep things simple, we're not going to work with RGB values. However, just know that if you really wanted to, you could change the color type within Python Turtle, and then you can simply put these RGB values to create literally every single possible color that could potentially exist. And so our RGB values are often the ways that we can that we create colors within our computer graphics with these values represented by 0, some number between 0 and 255. But like I mentioned, we're going to keep things simple for today and just use some name colors so that we can, I guess, move on and learn some other interesting stuff as well. Okay, how can we turn? So all I could do as of now is I can move my turtle to the right, and I can move my turtle to the left using those forwards and backwards commands. Well, I could go a step further and I can change it in the direction that it's going. And if you're curious, why is it heading towards the right? Well, the reason why it was heading towards the right is because at the default setting, our Python turtle faces towards the right. So that moving forward is simply just about going in the direction that's already heading. So if I want to, I can change the direction that it's going by using this right or left command. So let's change that and see what happens here. And I run my code. And do you guys see how my turtle is facing in the downwards direction? So my turtle is facing in the downwards direction. And then let's see what happens when I move it forward after. And we can move it any number of pixels that you want to. My turtle's name is 10. Okay, so I run my code, and do you see how I went forward, but I had to change that forward direction first. I had to move to the right in order to move it facing down. Okay, what does 90 mean? 90 pixels, 90 something else? Does anyone have any guesses for me what we could possibly mean when we're talking about 90? Maybe if you have some math experience, that 90 has a special meaning to us mathematicians. See if I can call on someone new. Derek Lee, can you help me out? What does 90 mean?
90 degrees.
That's right, 90 degrees. So this is when we're talking about math, and in my next slide over here, let me show you about this. So if you already have some basic math training about sort of angles, what we know is that we can measure an angle with degrees. So degrees is one of the ways in which we can measure an angle, and that sort of tells us sort of how big our angle is. And so for us in Python Turtle, that's going to tell us how much we want to rotate our turtle by. So for example, if we just wanted to change it a little bit, sort of on the halfway, 45, then we could enter 45. So let's go back to my code here. And let's say I did a right turn by 45 degrees. Which way is it going to go right now? Well, do you guys see how it was facing towards the right? It was facing towards the right. And then I moved it forward. I moved it to the right 90 degrees. Sorry, not 90 degrees, 45 degrees. So it went at the 45-degree angle, and then it moved forward. And I could do the same thing for a left. It would just simply shift in the other direction. And I run my code, and I can see there's my turtle facing the other way. Okay, great. So yeah, so if you're interested, how much do I need my turtle to move in order to go in a specific direction? All you have to do is make yourself familiar with the degrees. For example, turning the opposite direction would be 180 degrees, or going all the way back again, 365 degrees. But oftentimes we're going to be turning our turtle at 90-degree angles to simply change the direction that it's going in, but you can place whatever you want to. And even if you wanted to, you could do negative degrees. It's kind of a weird thing to think about if you want to, but going in the it would just simply help us to move in the opposite direction that we normally would. So if we had our left turn 45 degrees, but it's a negative degrees, then it would simply go in the opposite direction. That's just a fun, interesting thing. But we don't, I guess most people would just keep it simple and simply change the text to change it to move right instead. Okay, I've done a lot of talking today. It's time for me to take a little break. So I want you to use your skills that you learned so far and those turtle commands in order to draw this picture here, which is a perfect square. Okay. Now, if you want to, you can mimic this exactly with the same exact turtle shape. And if you, the idea of this challenge is to simply draw a square. However, if you finished, make sure that you are as detail oriented as possible. Make sure that your turtle is facing in these exact direction at the end to match this picture. Okay? So let's just take a couple minutes here to work on this exercise. If you get stuck, don't worry. We're going to do this. We're going to do this together. So she said, Teacher Brendan, I totally forgot to write down the commands. I don't know how to move left. I don't know how to go forward. Just remember your turtle's name and then right and the degrees and how to move it forward or backwards. It's with the dot forward or the dot backwards commands. Okay. I'll show you the square so you can see it again. Oh, interesting question. How do you change the color of the line? Well, technically this exercise just has the default color black line. But if you wanted to change that that pen color, you could do this. The name of your turtle and then pen color and then give it a color. Or like I mentioned, you could always go online and look up Python turtle colors and see all the different options that you have. But in this case, we don't need to for this exercise. Okay, I think one more minute. We'll take one more minute to complete this one. And if you didn't get it, that's totally okay. We're going to review all together. All right, some of you guys are sending me your code. Very awesome. Very good job. Great job. Okay. All right. I think it's my turn to come back here and show some code. So let's go back and let's write the code together. So I don't need pen color here. I do need my turtle. I don't need to give it the shape because I'm just going to use the default one to match the picture. So now my job is to draw that square. Well, I need to draw 4 lines, right? That the 4 lines represent the square. And then what we notice is that I'll have to, as I draw each line, I'll want to do a 90-degree turn in order to make sure that my turtle is heading in the next direction that it needs to. So it looks like I'll go forward, maybe 100 or 50 or whatever you would like it to be. And then I'll do a right turn if I sort of, think about it that way. I'll go forward again, I'll do a right turn, I'll go forward again, and then finally, to change my turtle in the original direction, I'll need to do a right turn. So let's write that together. So here's my turtle. He's going to go forward first, and then he's going to turn to the right, and he's going to go 90 degrees. And then I just do that over again. I guess in this case, I can just copy and paste, right? Here. Okay, let's run my code. And here is my square. So remember, how does that work? Well, a square is represented by 4 lines of equal length. So these 4 lines of equal length, all equal sides. And it has these 4 90-degree angles in the corners of my square. So I can represent that by simply turning my turtle in order to move it in the new direction so that I can move forward all together again. Okay, so here's my code. Your code might look similar. Maybe you put a different distance for how much the turtle moves. It's just important that whatever number you select, it's all the same so that you actually create a a square. If not, it won't connect. And that your angles are 90 degrees. If you don't have 90-degree angles, then it won't quite work as expected. Okay, so that being said, let's try this one. This one is a little bit more challenging than the last one, okay? So take a moment here. Let's see if you can use what, some of those skills Teacher Brendan taught you about moving forward and backwards and turning and all that kind of stuff. See if you can recreate this photo. Okay, I'm going to put the chat open in case I see some questions. Or you guys can feel free to submit your code to me if you like. Okay, let's take about 1 more minute. If you haven't finished, that's okay. We're going to review together. All right, let's review together. If you're sending me your code or asking questions and I didn't respond, I'm so sorry. There are a lot of messages being sent to me and sort of losing track of them. So I apologize if I'm missing your question. But let's get started on this one here. So there are a number of different ways that you can approach it. The way that I think I'm going to approach it is I'm going to move my turtle forward and it's going to move to the right. And then what I'm going to do is I'm going to move it backwards, double the distance. And that way it's going to make that left side of this plus. Then I'm going to move it back to the middle again. And then I'll rotate it either up or down, like left or right. And then I'll simply do the same step. I'll go forward and then I'll go back double the distance, okay? Let's see if we could do that. Let's look at our drawing and see if we can write our code. So he'll move forward and then I need to move him back double the distance to go in the opposite direction. So I can say backwards. Okay. And so in that case, what I see is, do you see how from the middle it moved to the right and then back, and then I need to move it back to the, oh, sorry, double the distance. Need to move it forward again to the middle. So let's see that part. So I've gone forward, I've gone backwards, double the distance, and then I moved my turtle back to the middle again. And so here's my turtle Ted, he's back to the middle. And then now I need to rotate him either up or down and do that same type of movement. So I'm going to rotate him to the left to point him facing upwards. and that's going to be 90 degrees. And let's do the same thing. Let's go forward and backwards. Forwards up 100 and then backwards double the distance. And we try that. And there we have it. There's my plus sign, exactly like the one from the photo, even with the arrow facing the exact same way. Your code might look slightly different. Maybe you rotated it down instead of up, or maybe instead of going back double the distance, you had 2 back commands. Maybe the first one went back 100, and then that took you to the middle, and then you went backward again, and it's the same thing, right? It's just different ways of creating the same task, and depending on how your mind works, you might have decided to move in a different direction than how I did. So ultimately, what's important is that we are able to recreate this plus sign with our code. Okay, great. So one thing I want to point out about this is that we are writing the same thing over and over again when we are drawing our square, which is forward, right, forward, right, forward, right, forward, right. Now, let's think about it this way. Let's say that teacher Brendan asked you, hey, can you create a heptadecagon, 17-sided polygon, or maybe even something crazier, like a 30-sided polygon, right? How would we do that? Well, you already know how to make a square. Well, what we would need is, for the more sides that our polygon has, it's just going to have more lines. And then we're always going to have the same angle amount, but it's going to be slightly different angle that we move from each time. But what we're going to realize is that it's a lot of code that we're writing that does the exact same thing. So is there a way that we could do this without just using copy and paste? Because just looking at it, it's kind of hard to tell what's going on. Now, I will tell you that coding is our way of doing repetitive steps over and over again that would otherwise be very challenging for humans to do, especially calculations and things like that. So there is a way in programming in which we can tell our machine to repeat a specific set of steps over and over again, a specific number of times. And that's called a loop. In this case, what we're going to do is we are going to say, let's first copy this code and go to our editor. We'll go to our editor here. And instead of writing all this code here, what we're going to, I need to fix the spacing. It's very important, the spacing in Python, that we use a tab inside of this loop. So I write for. Now I'll have a variable name. This could be whatever I want it to be. In this case, I'm not actually using it inside my loop, but this holds the values 0, 1, 2, 3. And then what I'll do is I'm saying, okay, Python, repeat these lines, the ones that are indented, 4 times. Okay, so it's going to do these 2 steps and it's going to repeat them 4 times. So when I run my code, I get the exact same output as I did before. And all I had to write was these instructions to tell Python to do a loop. And I just said, repeat these specific lines 4 times. And so that was my way to do this repetitive task, just by simply saying, repeat these specific lines. And so if you were to go back to the original problem, how could I draw a 17-sided polygon? Well, really the only hard work is for you to figure out what is the angle that you need to create for a 17-sided polygon. And you would simply go and copy and paste the code and say, okay, for 17 times, we need to draw a straight line, and then we need to turn at that specific angle for our polygon. Okay? Now, this was just a small introduction into the world of Python Turtle and this library that we have in order to make these drawings. You can really go as far with this as you want. When we learned this in the XCamp 100 class, there's a lot of cool stuff that we get to learn. So today, all we did was really draw lines. We'll learn how to draw circles or non-trivial shapes. We'll be able to change the turtle's speed so it goes either faster or slower. We'll learn how to change the screen color. how to pick up and put down the pen so the turtle's not always just dragging along the pen wherever it goes, how to clear the screen if at a specific moment you want to clear your drawing, fill a specific shape. So we made a square today, but we don't know how to fill it in yet. And then even taking a step further, we can make animations, and even go one step further is we can listen to input, and based on that, we can create something, a drawing that's interactive, or essentially some sort of game or user interface where we either click the button or press some key, and our drawing does something based on that input. So there is a lot of really cool stuff that we get to learn. But unfortunately today we only have an hour and a half for our class, so we don't get to learn all that stuff. Or if you are interested in learning those things, and you feel like this is sort of the right level for you, then this would be a good place for you to start so that you could keep learning the Python language and exploring using the basics of Python Turtle. Now, if this class were a little bit easy for you, and you said, I already know all this stuff about loops and all that stuff, I don't really need to get started with Python Turtle. I want to go a little bit faster, a little bit more advanced. Of course, we have other classes for you to potentially join as well. And so don't feel like this is all of XCamp. XCamp is a wide variety of classes, but this is sort of our starting point, is learning the beginning of Python programming language with these graphics, these turtle graphics. Okay, so beyond just Python Turtle, there is so much that we can potentially do when we're writing code. And so it really is, when you start learning to write code, it truly is a really magical thing. And even just what we saw with the loops and the way that we can create these really repetitive steps simply by writing one line for I in range or for X in range. It's very, very powerful, and it could help us to do a lot of things. So beyond just creating these cool pictures and writing some loops to make our life a little bit easier, there's more that we can do. For example, one way in which we make our life easier through our code is something called an algorithm, or algorithms if you've heard of them. So let's talk about these algorithms. What are they and where do we see them in real life? Well, all an algorithm is our recipe or our set of instructions that our computer should follow in order to carry out some task. So I'm going to give you a couple examples that you can see. So let's take a look at this picture here at the bottom left-hand corner. This is just a maze, right? It's a maze. We have this character, which is in the bottom, and it looks like our character is trying to make his way out of the maze to reach the planet over here. So he's trying to go through the galaxy and figure out where that planet is. Now, how would we do something like this, right? Well, if we were just doing this by hand, we would take our pencil and we would start drawing, and we'd kind of look with our eyes and see as much as possible if we could make sure not to go down maybe some trap paths like this one over here, and sort of see. And maybe if we got stuck along the way, we can go backwards and try a different route until eventually we made it to the end. So that's one way of doing it. But our computers are not able to sort of think and act in the same way that we would, right? We have to be very specific with our instructions that we give to the computer. In this case, I would need to tell my computer, in every situation, how do I need to move? Do I need to move up, down, left, or right? And how could it sort of look ahead and see what the potential route that might be more successful than another one? It doesn't really know, right? So in this case, we would need to write a set of instructions to decide, okay, when I hit the wall, I'm going to turn around and I'm going to go back to the previous step where I could have, I went left, but I could go instead to the right. So that's a little bit hard to think about of how we write that with code. However, this is something that we learn to solve when we get up into the 201 and 202 level classes, where we use algorithms, specifically something called breadth first search and depth first search, in order to search different spaces, for example, a maze, or other things like that, a graph, other things, in order to simply find if there exists a path to the end, or find what's the shortest path to the end, or how many paths exists from the start to the end. There's a lot of different problems that we can solve using different algorithms. And so that's something that's pretty interesting that we can do. Another algorithm that is very, very common and something that is used all over the place is this algorithm called the binary search. Now, before I tell you how it works, I want to give you an example. Let's say that teacher Brendan gave you a book and he said to you, okay, open this book and I want you to find where let's say it's a dictionary. I want you to find where a specific definition for a word is. Okay? Well, a dictionary has some order to it, right? It's in alphabetical order. So I might flip the book open and I'm at the middle page. And then I realize, oh, okay, well, let's say that it started with a a B or something like that. I would want to, flip to the other side so I'm closer to the start where the B is. And I'd sort of flip back and forth until I get closer and closer to my answer of what I was looking for. So this is similar to that idea. So let's say we were playing some guessing game. I said, hey, I'm thinking of a number between 1 and 100. Can you guess that number in as few tries as possible? Well, the best way to go about it is to simply say, I'm going to guess the middle number. And if that's your number, great. But if it's not, and you say that it's higher or lower, let's say that you say it's higher, I can immediately eliminate all the numbers between 1 and 50 and know that they are not a potential answer. However, if I guessed 1 and I said that it was bigger, I've only eliminated one potential answer. So that doesn't help me as much if I try and chop it in half every single time. So that's an example of how we can quickly search for items in some ordered space or some arranged values is by simply doing something like this that we'll learn in the future, where we could simply jump to the middle, check to see if our item is bigger or lower than the middle position, change our search space, and if we hit our item, then we're done. And if not, then we can loop. This is a different type of loop called a while loop. We can just keep on looping until we close that search space into something even smaller. And then beyond algorithms, we have there's a lot more that we can do with our computer programming. And one of the things that we will learn as we get better with Python are these data structures. So for example, in this photo here, we have some people lining up for, it looks like this this screen where you get to put in your order for your boba tea, right? So I see the thumbs up, someone likes boba. Yeah. Yeah, so yeah, how would we order that? Well, we would get in the line, we'd wait for our turn, we would start from the back, we would work our way up to the front, and when it's our turn, we put in our order, and when it's all done, we're gonna wait for our boba to be made, and when it's all done, then I get to go and pick it up. Well, how is that data organized and stored? It's stored in something that we call a queue, okay? So in this queue structure, it's a way that we can organize our data in such that the people at the front, or the data at the front of the queue, gets to be processed or accessed first. And then as soon as they get to leave the line, and everyone will shift up so the next person will then get to move up to the top of the line or the queue, and so on and so forth. If someone's going to enter our line, they need to come at the very end here. So this is the order that we can represent with our data. Now, this is really important, and technically that the order system is using this structure, right? How does it know whose drink should be made first? It only makes sense that whoever ordered first they should have their drink made first. They deserve to, they were first, and so their drink should be processed first. And of course, sometimes maybe a drink takes longer time than others to be made, but at least they'll be processed in that order. And so that's a data structure, a way that we can organize our data to represent this real life situation. Now, there is so much more that we can do with this queue beyond just keep track of people's orders. That you will see that there's tons and tons of ways that we can use this. And even we can use this data structure in order to solve this maze. And you're going to say, I don't understand, Teacher Brendan. How does that possibly work? That's something that we will learn in the future, is how we can make that connection in order to use that. Another thing that we have as a representation is this data structure called a stack. So it's a little bit similar idea from the queue, but when we think about a stack, we often think about like a pile, and maybe it's a pile of books or something else. But the idea is that when I add a new book to my pile, I'm going to put it at the top of the pile or the top of the stack. And if I want to take out an item from my pile, I need to remove the ones from the top first before I grab the book that I need. And so this is another data structure or way of storing our data and representing it in a way that represents what we have in real life. And this is another example of this data representation can be used to actually solve this maze puzzle. So there's a lot of ways that people have been very clever to use these data structures in combination with different algorithms to solve very complex problems, okay? Now, for us, we are at the very beginning journey of learning about computer programming, and with time, we will be able to learn about different algorithms, different data structures, and even just what problems are possible for us to solve, and what are the different ways that we can go about doing that. So, although that the stuff at the end is something that is for another day, it's something for us to learn in a higher level XCamp class. Hopefully, it sort of makes you interested in this idea that there are a lot of interesting problems that we can solve just with the way in which we write our Python code. And after our class today, we already know the very first steps in writing our Python code. And hopefully that will continue you on your journey with programming to go even further with the Python language and maybe with some other languages as well. And like I mentioned, for whatever level you are, whether you are just at the very entry level of learning programming, and this is brand new to you, we have our 100 level class. And even if you already know about programming, we have classes as well for you where it could fit your level and still be a challenge and be a setting for you to learn. So that's all I have for today. That is our class. I hope you enjoyed this trial class. I hope that you are interested in XCamp, and maybe even I'll get to see some of you as future students in my classroom. So you guys were an amazing class today. Give yourself a round of applause. Great job. You learned a ton, and I had a great time being your teacher. So now what we're going to do is I'm going to turn it over to our owner, Charlie, and Charlie is going to talk to the parents a little bit more about the big picture structure of how XCamp works with the different classes, registration, sign up, and things like that. So if your parents are close by or they're joining from the computer, please ask them to come, and Charlie will talk to us. And then after, he'll be able to answer some of your parents' questions. Okay? All right. Thank you, everyone, and have a good rest of your evening.
Thank you, Brandon. Yes, students, this is Charlie. I'm the co-founder and the principal for XCamp. Please, call your parents to join this meeting now. So we have, it's kind of a post-class open house for the parents. And the students, you are welcome to stay here too. Thank you again, Brandon. Out of the students, congratulations. You have complete kind of the first class, maybe a first class of Python. This might be a milestone in your learning experience. Yes. So let me see if the parents join your meeting. if you can turn on your camera, I can see if your parents are there. Yeah, Joyce, would you please share the screen and show.
Okay. Can you see a screen?
Yes, can you do the screen share? Yeah, thank you, thank you. Yeah, this is the post-class meeting. So we would like to provide more information about XCamp's class, XCamp's history, XCamp's philosophy of teaching. Hope you learn more about us, especially you might make decision if you want to continue the coding journey or not. Next, please. So we will have a introduction first. Yes, please click the video. It's about 2 minutes about XCamp.
Okay. Oh, but maybe I will share again with the video.
Okay, that's okay. Joyce, there's no voice.
Okay.
Let me just
Yeah,
share the tab. Just share the tab.
Yes. Oh, sorry. Okay, this is not the.
Sorry, I also got a vacation tomorrow. I'm packing now.
Okay.
Also
Yeah.
just a drive out.
Is a community dedicated to inspiring and cultivating the next generation of computer science and artificial intelligence talent. XCamp Academy was founded in August 2017 in Silicon Valley by 2 Google software engineers. The name XCamp was inspired by the variable X, which represents unlimited opportunities. XCamp's curriculum system and training methodology is inherited from Mr. Xian Youxu, a Chinese diamond-level international gold medal coach. Our staff here in the US is mostly composed of senior software engineers from tech companies in Silicon Valley and prestigious CS students from top universities. In addition, we have strong support from international and domestic competition winners in our coach team. From beginner-level Python to classic C++ courses and competition honors courses, XCamp's curriculum is designed for students of all different levels. By participating in team-based competitions and facilitating frequent group study sessions, XCamp also fosters an environment of collaboration to build each student's confidence in their ability to code. As of mid-2024, more than 300 XCamp students have reached the USICO Silver Division and above, including 60 in the Platinum Division, and 27 were selected in the US and Canada national camps, out of which 15 were fresh in the 2024 season and 2 were selected for the US national team. In renowned high school contests, Stanford's Procol and UC Berkeley's Calico, and other prestigious US programming competitions, such as the Harvard Programming Invitational, Teams Code, and Lexington Informatics Tournament, XCamp students perform well, and we encourage students from being participants to problem writers and organizers. Our students received 13 MIT offers and many more from Stanford and UC Berkeley, thrilling us all. Here at XCamp, we believe that children have unlimited potential and can change the world through coding.
Yeah, you might know here's a quick introduction about myself and the co-founder of Yuan. We both worked in Google 7 years ago, created this XCamp. So I had a PhD in AI from UCLA. Yuan had a master's from Columbia. So both of us have worked in Google. I worked more than 11 years, Yuan worked more than 8 years. Now both of us quit Google job, now work on XCamp full time. Next slide, please. I think you have just learned this trial class. It's a quick summary. We teach you about the translate the logic into code. Also, we will get you ability and confidence in coding. So hopefully we would like to inspire your passion and love in coding too. For the next, so we have some coding tasks. If you are interested, you can continue working on that. In addition, we have the after class homework, so you can try more. You know, the turtle coding is pretty fun. You can draw a lot of things you are interested in. Next slide, please. So why we choose Python as our coding language for beginners? There are several reasons. First, it's a low entry barrier. So for the learners, especially some elementary, middle school, high schoolers, so it will allow you to learn quickly because the syntax is more close to our natural language. Also, it's easier to have more useful applications. So like web development, especially the data analysis and the AI machine learnings. So the Python is the first choice of the language. In addition, after you learn Python, it will be easy for you to switch to Java, to C++, and other languages. Next, please. So if you look around, especially in the Bay Area, learn coding is a very popular topic. It's more important, I think, is will help us to create computational thinking. This is very important to have our kids have this computational logic when they are very young. You see in the Seattle area, there's a high school, middle school students, they start learning coding. Next, please. Let's talk about the roadmap, Joyce, last slide. Next one. Yes. So at X Camp, we show, the competitive coding results. However, that's only few, only few students would like to complete the competitive coding journey, which means you might join the US National USACO team, or you might go to the ROI. It's kind of International Olympiad of Mathematics. Before that, I like to say there's a lot of opportunities for you after you learn coding. If you just finish the Python, it will be very convenient for you to, as I just mentioned, to have some fun coding, to do data analysis, to do some AI too. At XCamp, if you study with us 2 to 3 years, you will finish the intermediate level and advanced level coding. Some of you could pass Google's algorithm and data structure interview. That's another big step. So if you want to study computer science, if you might pursue computer science as your career, after 2 to 3 years, I believe most of you will have the capability to work on this interview. We will not have much challenges. Yes. Also, after that, if you have this foundation, you can work more on the AI projects. Also, do more on the research. We have a lot of students have proved coding experience is the fundamental skills they can use in the future work. Next, please. Here's our faculty team. Like me and Yuan, we from high-tech companies here, like a lot of our teachers from Google, Meta, Microsoft, high-tech company. Also, some they have strong backgrounds on the competitive coding. Next slides. We also have some students from top-tier colleges like MIT, Stanford, Berkeley. Also, we have a lot of medalists in the competitive coding. Next. Here again, about our achievements. I want to skip this one. Next. Here we list more about our teaching materials and the package. So we not only have the classes, it's instructions in the class, but also we have homework night. So every night 5 to 8, you can join our Zoom. You can ask any question. You can work on home together in the Zoom. Also, we have a platform called Discord. You can ask any questions there too. Also, we have educational forums like parents and the students. You can join our forum, learn from the speakers, learn others' experience. Also, we have contests like we organize students to join a lot of contests like Berkeley's Calico, Stanford's Proto. So yes, also I like to say that placement test for the every students. I think most of you might start from the beginning class, but in our system, we believe the best class is the suitable one. So also we have the 4.0 award plan. So if you do good, you have most kind of A students, you will have the 4.0 award. Yes, next please. Yeah, here's again, it's like a link, all this about our learning full package, which means we not only provide classes for you to learn the knowledge, but also we provide a platform for you to support you. Yes, next. Yeah, here's the examples of previous student project. These are examples of our first class 100 class students project results. So our fall class will start at the end of September. It's September 25th. So we have weekly class. Also, we have our mock test and a high-level grandmaster class. Also, we have our AI class. So after you learn Python, so you might also attend our AI courses. Yeah, next, please. So let's I use 50 minutes to give you a quick introduction about XCamp. If you have any questions, let's jump into the QA session. Yeah, you can just open your mic and answer question directly, or you can raise your hand.
Okay.
Our parents, if you feel comfortable to ask in English or even Chinese, either are okay.
Okay, Max. Okay, Max 在举 raise his hand. Okay, Max, please.
Max. I think we have, let me see.
Oh, they can't unmute themselves. Okay, let me check.
No, I can.
Okay.
Great, thank you.
Okay, please.
I think that's a good demo of the student work from in the video, but which class was that? Is that 100p or 101p?
That's 100 PV, 100p.
100p. So 100. So my main question is about which class my son should take. His math qualifies for both class 101 and 100, but it sounds like 100 is more fun.
Exactly. So that's the purpose of a 100. We purpose design 100 as a very, very fun class. So, but some students, they have the background of coding. They already have fun learn coding. They already have the interest in learning coding. So we have the opportunity for them to skip the 100 class. So conceptually, there's a more deeper, more kind of a logical thinking in the 101. It's not that intuitive for the 101. Yes.
Okay, so for a student does not really have much didn't really learn programming, so I guess your recommendation would be 100.
We kind of recommend 100 for this case. Yeah.
Okay, thank you.
Okay. Any questions?
Hi, I have two questions. So
Yes.
one is, are most of your class online or in person? So what kind of in-person classes do you provide and where is it? And the second question is, how do I evaluate my kids for his level? And the level is mostly decided by the math, like his math level, or what kind of coding background he has. So what's the main factor for deciding? Okay.
These are very good questions. First one for the in-person class, we started in the fall, have the in-person classes. Now we have in Sunnyvale, we plan to have Palo Alto, also maybe Cupertino, in South San Jose. So now we try to get the students. We have like 12 students. We will have in-person class from the fall. So may I know where is your location?
In Sunnyvale, but I don't see any in-person classes information on your website.
Exactly. Yeah, that's true. So we will ask the interested parents because currently Sunnyvale, the class is almost full. In other locations, we try to have some students who show interest first, then we make it public. So yeah, please contact our Joyce. So she will help to arrange for your in-person class. For this placement test, we have 2 placement tests. As also just the other parents ask. So if the students don't, have much coding experience, we will have a test on math and logic thinking. So this decide if the student qualify for 101 or not. But for some students, they qualify for 101, but still they would like to learn from 100. That's also a very good choice. If the student have the coding experience, we will have the student to do the coding placement test. We will give them 12, 15 coding problems. See how many they can finish. And from there, we will decide their class level.
Okay, got it. So the information you show here, the email or the phone number, or even the WhatsApp.
Yeah, yes, I have already put my contact information in the chat box. And then you also can go to our website. There will be scheduled 101 consultant to us.
Okay.
Probably you also have the WeChat assistant, the third barcode. So please just scan the third last one, the WeChat assistant.
The WeChat assistant.
Yeah, I think this is Joyce. It's Joyce one.
Yeah.
She can do now.
Yeah. It's me. The WeChat and the WhatsApp is all me.
Okay, got it. Because I would like to have more information on the in-person class and also the evaluation.
Yeah. I will give you the in-person information.
Okay, thank you.
Great.
And Aiden.
Yeah, I have 2 questions. One is for online classes. Typically, how many times do they meet every week? Is that only on weekends? So that's question number 1. Question number 2 is, I understand this is a Python class. For kids, can kids without doing Python directly learn, like Java first? And is there an introductory class for Java?
I may answer the second question first. So our first 3 classes, 101, 100, 101, and 102, they are Python class. For the from 200, we teach kids C++. Then we have our Java class. It's called the APCS 1, 2, and APCS booster class. This is in Java. This also can help students not only learn Java, but also to pass APCS in higher score. Yes. What's your first question again?
The first question is, I'm not in the Bay Area, so or Seattle, and Austin, Texas, and we'll be taking the online classes. How many times per week? Is that class only offered on weekends?
Yes, most of our classes are on weekend. We may have 1 or 2 is Friday evenings. So we have a 2-hour instruction per week. For each class, we have 2-week instructions. Also, as I mentioned, only learning in class is not enough. So we have a homework night. So definitely we have homework, so the student can come to the homework night to work on the homework. Also, we have office hours for the low-level class because some students want to talk to the teachers, TAs directly. So we have office hours. They can come and have like a close discussion with the teachers or TAs.
Oh, okay, and so what you show on the screen is basically the recommended sequence for classes. My son is slightly higher grades. He's incoming the high school freshman. He hasn't taken how to say the official programming language, but he has taken some elective in more like HTML, JavaScript, etc. So I'm trying to figure out which level he may be ideally placed in.
Yes, we will have the placement test. We will give him the coding test. Yes, please contact Joyce. So she will arrange for you for that. Yes.
Okay. Is the coding test in Python?
You can choose any language. The test you can use Python, Java, or C++. Any language is okay.
Okay, wonderful. Thank you.
Sure. Yeah, parents sending me the private message. Let me answer here. What's our syllabus for our 100, 101, 102, and the 200, 201, 222 classes? Please check our website. On our website, we have a detailed list on the contents to be taught in the class.
Yeah,
next.
Eric, please.
就是我们小孩在今天上课之前做了一个数学的 test 嘛，所以那个不是 placement test 是吧？那个placement test 就是那种 Python 的 test 是吗？
我们有2种 placement test。刚才说第一种呢，就是孩子之前没有过编程经验的呢，就是你孩子做这个数学和 logic placement test。这个 test 是决定他是上100还是101。当然理论上讲的话，其实所有的孩子都可以从100上去都比较好，但有些孩子的话，他想上101就 skip 这个 visualization 的这个课程，那我们是需要他要有更好的 logic thinking 才可以。
所以今天的课是大概是什么 level？ 是100还是101？
这是100入门的 level 的，对。
OK。
假如孩子觉得很轻松的话，假如他之前有了 coding experience，至少可能半年吧，就是说可以试一下，就是说我们 coding 的 problem， 这样的话有可能会从102开始。
他之前上过一点点的 Python， 所以其他的都没有学过，所以
那可以那你可以联系我，让他先做一下编程的测试，如果他不会做的话，再做一下数学测试就可以。
OK， 好的，谢谢。
Okay, Wharton, please. Hello? 他可能不在。刚才我好像看到有一个家长举手。那个，
你好。
你好。
你好，是这样，就是我们现在在欧洲，我想请问一下，将来会不会考虑开一些适合欧洲时间的课程？我们现在差不多是凌晨3，我现在在国内嘛，但是在欧洲的时间现在是凌晨差不多3点，所以就是说能不能以后有没有就是比较适合欧洲的这个的时间？
我们其实现在也是在准备做一些这个国际市场拓展了，包括中国那边的话，也有专门给中国开的班。假如我们现在是有一个叫做这个家长追问的一个需求哈，假如说你周围有朋友或者欧洲你能够组团有12个学生的，我们是可以给你特别的来开一个班。你主要的周围有这么多朋友来上这个班吗？和你孩子年纪差不多的？
现在还不知道，但是我可以问一下，就是说，比如说，但是我们跟国内相差的时差是7到8个小时，就是比如说是国内的晚上是我们的白天，就是他们的下午是我们的白天。其实我们也如果是可以，也可以跟那个国内的这样合在一起上课。
那也可以，假如能找到一个合适的时间的话，也基本上我们还是争取来满足你们的需求。对。
对，如果您那里就是有这种国内的上午的时间，那么对我们不对，国内的下午或者晚上的时间，对我们来说就比较合适了。
OK，我们现在是计划或者一直有一个中国对国内的班是他们的周六或者周日上午7、8、9点左右，可能对你们来讲还是不合适的。
我们
对。
我们最早的班是下午1点，应该是你们那边的晚上10点。如果按照你刚才说的时差的话，
对，如果国内的下午1点的话，是我们的
不是
早上。
是我们美西的1点。美
OK，
西时间的1点，
是我们几点？
是你们下午晚上10点。
哦，好，好，谢谢。
对，
行，这样吧，你加一下 Joyce
你加
微
我，
信，
对，
我们回头
加过，
讨论一下。
对，
对，
有加过，对。
好的，好的。
谢谢
然后
哈。
你对有孩子多的话，我们可以安排，或者考虑这个我们这边的时间找一个合适。对，好的，好的，谢谢，很高兴哈，你们从欧洲过来，
好，下一个那个测下是吗？是这样子吗
？CC，这样问一下你具
CC，
体的那个课的时间和我没看到，就是具体的课的时间 in person， 还有你们说的这些信息 in person 和 online 的时间。
你可以到我们的网站上去看一下。我们秋季的话是9月28号开始上课。
就是具体的星期几点在哪儿？
一般来说都是礼拜六或者礼拜天的下午上课，但是因为每一个班的时间不一样，所以要根据学生的测试的结果。
在什么地方可以看到这个要先测试是吗？因为我们有很多其他的活动。
对，就是我刚才看到我已经把我的那个联系方式都发给你了，你如果方便的话可以加我一下，或者把我的电话记下来，然后到时候给我打电话，我再给你发一些详细的 information。我们的课程基本上都是礼拜六下午或者是礼拜天的下午，然后有1到3点、3到5点、5到7点都有，所以要根据他的班级来确定他的上课的时间。当然我们礼拜六和礼拜天都有选，就是同一个 level 的班，礼拜六和礼拜天都会有课。
OK， 好，谢谢。
对，我们现在一般的 level 都有3、4个时间了，可以挑一个合适的。你刚才也问到线下的课，其实的确线下我们还没有公开，因为我们现在也是根据看看某不同的地方的一些需求了哪个地方需求比较多了，我们可以开始来开。您是在哪个地方？
我们在Sunset Downtown 附近。
Sunset Downtown。OK，那行，那我们这边假如说，其实我们现在正准备在这个Cupertino 或者是3号赛这边开一个线下班。你现在加一下小助手，你说一下你对线下班比较感兴趣。我们有的话就
谢谢
通知你。好的
OK， Robert 家长。
我也是那个同样的问题，就是线下班。我们是在 Los Altos， 然后看你如果要开的话，大概在什么地方？
我们现在很有可能在 Plato 这边会有一个班。
时间呢？大概什么时候？
会在9月20和这个班是一样，9月25号开课。
9月25号是吧？
对。
多大的那个确定性啊？就是说你们已经在计划当中，还是只是在构思啊？
其实我们现在是这样，就是我们基本上确定差不多，先私下里找够差不多的学生之后再公开最晚说一下，因为这个地点和时间的话，我们有时候公开来说不一定有足够的学生在那个位置。 应该只有2、3个星期吧，我们就会来通知你。这个还是一样了，你加一下小助手，我们有了就会通知你，好不好？
好的，好的。
对对
我们
对对对，
争取4、
你加
7
一下我，
小时了，对，
怎么加？
是
加那个
啊，我刚才发给你了，就是你看一下，你把联系方式你先 copy 一下，然后随便你用哪个方式跟我联系都可以，因为
你加
最好
微信，
他们
你把这个小助手，你把那个第3页最后一页那个你那个最后一个你的微信让他们扫一下就好了。
OK，那我再share 那个屏幕哈，因为最好就是他们在上课之前呢做一下那个入学的测试，因为不同的班级的话，我们其实有不同的安排。OK，好。
哦，就是这个是吧？第
3个，你第3个你
Yeah，
扫一下了，对。
哦，第3个是我
the second one，
加一下是吧？
最后一个，
Yeah
对。
好的，我
So
这
the
个
the middle one is my WhatsApp. So you
嗯
can scan WhatsApp if you use WhatsApp instead of WeChat.
好的，
好嘞，好嘞，
谢谢啊。
行，好，那看看大家还有别的问题吗？
我发现很多人都是很关心线下班。
线下班，对，那我们可能就要开线下班了。要么大家都加一下，最后哈，第3个那个小助手的微信，假如还没有加的话，因为这样以后我们联系起来也会比较方便。假如感兴趣的话，那今天如果报名的话，我们会有额外的50块钱的折扣。
对。另外那个查理，你要说一下那个100班有一个 promotion。
对，我们现在呢刚好是我们已经成立7周年我们对100班，就是说这个今天和 Trial Class 相关、相似的了，接着学的那个班，会有一个15%的折扣，对所有的学生都有额外一个15%的折扣是为了我们庆祝7周年的。那个折扣可以和 Early Bird 和今天的50块钱折扣一起叠加。
没有，我更正一下，没有 early bird，就是我重复一下，就是100班就是我们今天上课的这个内容，比较适合5、6年级的孩子，他刚刚入门这个想学编程教育，从编程学习从兴趣入手的这个班其实比较方便。如果孩子年纪比较小，然后还没有学过编程的话，是比较建议从100班开始。他原来是学费是800，然后我们因为庆祝7周年，现在学费是680，然后这个680是不分早鸟的，就是一直到开课之前的报名都一直是680。然后如果你跟冬季课程，就明年1月份开始的冬季课程同时报的话，那还会有一个2期合报的优惠，就是可以再优惠50。另外冬季的那个课程，另外还有50的早鸟优惠，所以2期合报的话是总共是680，再加上那个101班的学费再优惠100块这样子。
好的，谢谢 Joyce。
对，如果对刚才校长也说了，如果是今天就报名的话，是可以再有额外的50块钱的学费优惠。对，只仅限今天这个50。
好的。对，
对，
应该今天有几个不少哈，10几个、20个这个我的谷歌的同事来听的假如你们孩子感兴趣或者有什么其他的需求的话，我想也许我们给你们谷歌开一个线下班，给我们谷歌开一个线下班，包括哈克了，哈克家长假如你们有感兴趣线下的话，我想也给哈克或者在我们南3号赛这边开一个线下班。好的。好，看看大家还有别的问题吗？刚才说那个680是线上班的这个价格哈，我们假如线下的话，现在会加一个线下的这个房子的费用和老师的费用，额外的费用。
OK，
好的。
那个 CC 又举手了，就是还有别的问题吗？没有。
好，如果没有问题的话，那我们就到这里假如真的有问题的话，再可以私下里和我们小助手Joyce联系。谢谢大家。
好，谢谢大家。
拜拜。